So I strongly recommend using this text as a reference for Python. There's lots of places where you can get Python help, but the one that I'm going to mention, table of contents, PowerPoints, top link is now How to Think Like a Computer Scientist. It takes you to a web page, which is called a open source text. Online, free to use for anybody. Doesn't have any quizzes, doesn't have anything like that. So, chapter 1, we're not going to go through this line by line. Doesn't mean that it's not really good, it's just that I'm not going to spend 2 class periods catching up from this page back to where we are in the book. It introduces the Python prompt, which we've also been calling the shell. It talks about a different editor other than idle. If you feel like downloading PyScripter, you can do so. Give it a shot, see if you like it better. What is a program? It gets input, gets output, it can perform math, it's got conditional execution, also known as selection. I think our textbook has been calling it selection. This is calling it conditional execution. That's your if statements. If, do something, or if, else, or if, elif, else. And a repetition, which we've been calling looping. What is debugging? Debugging is the practice of tracking down problems. This says that there's 3 kinds of errors: syntax errors, runtime errors, and semantic errors. I believe that our book called them something slightly different. I'd have to go back and check. But this is all very good information. You can use this as your Python resource more than as for answering quizzes from the book. Use the book for the exam, for the mind tap test, right? Because it'll be using the exact language that it wants. All right, I'm going to scroll past all that. That's chapter 1. How to Think Like a Computer Scientist. Chapter 2, variables, expressions, and statements. Well worth reading. Like, here's a variable. It's a string called what's message, and they store what's up doc in it. And then they create another variable called in, and they store an integer in it. And they create another variable called pi, and they store a float in it. If you try to reverse it, if you try to put the literal, the constant, on the left-hand side, you get an error. Just because of syntax. The syntax has to be the variable on the left-hand side and the other value, the literal, the constant, or the other variable that you're copying from on the right-hand side. Python has 30-something keywords. These are words that we can't redefine. These are the words that make up the language. So far, we've only used some of them. We've used if, elif, else. We've used def. We may have used or and, right? We've used probably true and false, and while to do our loops. So we've covered like a third of them. That's okay. A lot of these are kind of above where we're going to go. I really doubt we're going to use that keyword, for example. Not really planning on introducing finally. Exec, not going to talk about that. Exec is a very dangerous keyword to use. So to a certain point, I may mention it just to tell you not to do it. Yield, not going to talk about that one. But we're going to know a goodly percentage of these by the time we're done. If the compiler complains about one of your variable names, check to see if it's on this list. Now, honestly, are you going to be sticking the word? Well, I guess you could put raise as a variable name. You're giving somebody a raise, but that would be an error. It'd give you a syntax error. And then statements versus an expression. An expression is just something that creates a value. 1 plus 1 is an expression. The length of this string is an expression. And then a statement is something that does something with expressions or otherwise, right? A equals 1 plus 1 is a statement. Just saying 1 plus 1, yeah, it does something. It creates a value too, but it didn't store it anywhere. So it's an instruction that the Python interpreter can execute. This is saying we've only seen the assignment statement so far, but we've seen other ones. You know, creating turtles and telling them to go left and right and defining functions, modules, and calling them. This text is not going to call them modules at all. I consider that a non-standard terminology that this book uses. Operators and operands. If we're looking at this sentence, which is the operator? I have covered this, so somebody ought to know.
The operator is the asterisk, right?
Right. The asterisk is the operator. The operator is the mathematical symbol. Plus, minus, divide, star, star, multiply. That's the operator. And the operand are the pieces of data it works on. 2 and 3 are operands. Star, star is the operator. Let me zoom in on that. That's probably too small for the folks in the back. I used to have an extension that would increase just the font size without zooming in anything else. Here we go. I keep meaning to switch from Chrome to Firefox, but I just love my extensions too much. Type converter functions. We've been using these all along. We haven't been using int too much because we kind of really like floats, right? If we're going to take this string that the user typed in and we want to do some math on it, we have to either convert it to an int or a float. Why not convert it to a float so that they can type in fractions, right? I'm 17.5 years old. You know, or if somebody's really concerned about their weight, they may know the fraction of their weight. You know, I weigh 131.5 pounds, something like that. So pretty much we've always been using float, but there are going to be times when we would like to use an int. And in that case, you'd want to turn it into int for a whole number. So far, the only time I've seen it come up when it was really important is if we had a range statement. The range statement requires ints as its arguments. So if you get some input, you better turn it into an int with int rather than a float. We may as well do that right now just to make sure that we have that concept going, because we've been using float the whole time, and then I used float in the code when I was demonstrating it, and it gave me an error. So I needed to remember this. Why not remind you all of it as well? Looks like we're on K. My obligatory mention, don't save things in a Python subdirectory, and don't call it math or turtle. I only say that because in the other class, people had done one or the other, and one of them broke Python completely, and the other one stopped their turtle program from working. Oops, not J, K. So the good old stuff. Oh, gosh. Sorry about that. I have a Bluetooth tracker on my wallet, and when I sit on it wrong, it decides to call my iPad to tell me where it is. Alrighty. CIT1113. Today's date, March 6th. We're kind of doing a little bit of a review at this point, and then we're going to go on to Chapter 3. So I may as well put that as a comment. Review in Chapter 3. What have we learned so far? I'm going to reiterate the operator and the operand bit. If you have this expression, 3 plus 4, plus is the operator, and 3 and 4 are the operands. So the operators are the special symbols, not words, special symbols. I may regret saying that because technically the words and or are also operators, but they're more keywords. We already saw them called keywords, so forget that. We're going to just call them the special symbols. Operators are the symbols, like math symbols, and operands are the data they work on. So addition, subtraction, multiplication, star, star, floor division, modulus are all known as binary operators because they require 2 pieces of data. If you're going to do some subtraction, you have to say what you're going to subtract it from, right? It takes 2 pieces of data. There's really like only one so-called unary operator. And the unary operator means one operand, right? And that's just if you put a minus sign in front of the number, right? 3 plus minus 4. That minus is an operator that changes the value of 4 to a negative. I don't care about that. Might be a quiz question on the Mind Tap exam, but I don't think so. Not the last time I looked. Equal sign is also an operator. Anybody remember what we've been calling it? What is the act of copying a value into a variable called? Well, we've called it a whole bunch of things, right? We've called it, declaring a variable or initializing a variable. But technically, the equal sign is called the assignment operator. So A equals 5 assigns the value of 5 into A. And the reverse, 5 equals A, is a syntax error. Because the equal sign only works one way. 5 into A. Then there's another operator, something else we use the equal sign for. What is that? We've seen the equal sign used in two contexts. One is assignment statements. When else have we used the equal sign? We've been doing it since like day 2, so somebody cough it up, please. Say the wrong answer so I can correct you. What have we been using the equal sign for?
Show that something's representing something.
Double equals, exactly. Double equals, right? So double equal is the equality operator. It checks to see if two things are the same. So like if A equals 5. If you mess them up, if you just say if A equals 5, it's going to give you a syntax error. It'll tell you what line number or whatever, and it's pretty easy to fix. Some languages would not give you a syntax error if you just had if A equals 5. But it would do exactly what you didn't want it to do, which is erase your value of A and put a 5 in it. You don't want it erasing your data during a comparison. Fortunately, this language and a lot of newer languages don't let you make that mistake. So we've seen a lot of operators so far, right? Multiplication, division, addition, subtraction. We've seen a couple more. What do we call the percent sign? Don't make me hum the Jeopardy thing.
Do a remainder, doesn't it?
Yep, that does a remainder, and its technical name is modulus. Modulus. Can I spell? Yeah, there we go. And then star was what?
That's the X.
That's the exponent to the power of. And then lastly, divide. That was a special kind of division called, what am I pointing at? Not my foot, the flat thing, the floor division, right. Which just means round down the answer. 4//3 is just 1, right? Because 4 divided by 3 is 1.333, but if you use floor division, it rounds it down. May as well give those examples, right? 5 divided by 2 is equal to 2.5, but 5 floor division 2, do the division and round down. And then lastly, the remainder one, the modulus, 5% 2. Well, when we divided 2 into 5 and we got 2, what was the remainder? Don't say 0.5.
One more time, what did you say?
2 goes into 5 2 times with a remainder of,
0.5, right?
don't say 0.5.
Remainder of a half? Or,
It's a remainder of 1, right?
okay.
2 goes into 5 2 times, and I know why you're saying that, right?
I see.
But 2 goes into 5 2 times with 1 left over.
Right.
2 goes into, I love that phrase, goes into, like we're in the 3rd grade now. 2 goes into 5 2 times with a remainder of 1. you wanted to, there's a function which would take 2.5 and round it up. I think it's called math.ceil for ceiling, something like that. I don't know. I don't remember. I'm not going to ask you. Then, what if you want to round the number, right? What if you want to change 2.9 into its nearest whole number? To round, you use the round function. So x equals round 2.9 would equal 3. X equals round, and you know the rules, and I'm not going to try to trick you up by remembering whether 0.5 rounds up or down. I think it rounds up, but I'm not going to ask you that. So rounding 2.1 is equal to 2. But if you want, you could round something to decimal places. You can specify how many decimal places you want. Like if you had this, x equals 1.234, right, like that, but you want it rounded to 2 decimal places. You could do this, x equals round x, comma 2. What's it going to do? It's going to drop it's going to round it to 2 decimal places. So you're going to get 1.12. That's a good way of truncating your output, because we always see it do things like, 1.66666666, things like that, and you don't want to show the user all those sixes. You could round it. All right, I started taking the notes because I wanted to talk about range and int. Then I forgot to do that. So let's remind ourselves what range does. For x in range, parentheses, 1, 11, 1, and you don't have to put that many numbers here. If you're going up by ones, you can leave that one off. This counts, it loops from 1 to 10 by ones. For x in range 2, 11, 2, that counts from 2 to 10 by 2s. So 2, 4, 6, 8, 10. Why is it going up by 2s? Because of that one. If you leave off the first number, it starts at 0. If you leave off the last number, it always goes up by 1. So range, parentheses 10, counts from what? It starts at what? If you leave off the first number, what's it going to start at? Not going to start at 1. Somebody take a guess, so even if it's wrong, I can correct you.
0?
Yep. So it's going to start, it goes from 0 to 9. And I know you want to make it 1 to 10. Just remember that that's 1 past your stopping point. The parameters, the arguments for the range function have to be ints. They have to be whole numbers. Is that strictly true?
No.
There was something we used that required ints, but it's not true. Let's find out if it's true. I'm going to end my my notes with the triple quotes. For x in range, parentheses, I want to start at 0. I want to go up to 10, but I want to skip by 0.5 each time. That's not strictly good because it's also going to include 10.5 in the list. Well, let's see what happens. And then print x. Well, what do you know? It really does want me to use integers, so I'm not allowed to create a loop with the for loop. That'll go up by fractional amounts. All right. I'm going to delete that because I really wanted this one to count up by ones. But I am going to add a comment. Arguments, the arguments are the values that you put inside the parentheses that fill in the parameter variables for range must be ints, parentheses, whole numbers. Meaning that if I ask the user to enter a starting point or an ending point, I have to convert it to an int. So I'm going to put a comment here because I really don't want to have to type in a number every single time we test it. But the upper bounds equals, or we could call it max, upper is a better term, equals input, parentheses, like that, or input, enter upper. But then I'm going to just hard code it to a value, right? Let's pretend that they typed in 10. I need to turn that into an int. Here's what I could not do at this point. You don't even have to type this yet because it's wrong. For x in range, upper. That won't work. Why won't it work? Because upper is a string at this point and it needs to be a whole number. It can't even be a float. I guess you could type it because we're going to fix it. We're going to turn it into an int. How would we do that? We would do upper equals, but not use float. Instead we use int. Upper equals int, parentheses, upper, in parentheses. Now we can do for x in range upper and print out, right? Print, parentheses, quote, x equals, end quote, comma, x, close parentheses. Just to make it look different than the other one, right? Make sure I haven't put a syntax error in it, because if I do, y'all are going to do it. Okay. So, arguments for range must be ints. I'm going to add another comment. We had to convert upper from a string to an int to use it in a range. That's why we did upper equals int, parentheses, upper. I think I'm about ready to tab back to how to think like a computer scientist. Order of operations. We know these from high school or grade school or whatever. Multiplication and division happen before addition and subtraction. We can also call those precedents. Order of operation, parentheses, precedents. Parentheses happen first, then exponent, then multiplication, division, and also floor division and modulus are all considered part of the same tier. But we don't have those symbols on our calculator, so we didn't put that as part of the mnemonic. And then plus and minus. And so our abbreviations for those was that these are parentheses, these are exponents, MD stands for multiplication and division, and AS stands for addition and subtraction. The silly mnemonic, feel free to discard it immediately. Please excuse my dear Aunt Sally. And you really already know this stuff, I'm pretty sure. Like you know what this means. A equals 2 plus 3 times 4. What happens first? Right? Not the 2 plus. 3 times 4 happens first. So that's 12. And then it gets added to the 2. So that is the same thing as 2 plus 12, which is equal to 14. I ask a few questions about this on the exam, like that, and there's honestly nothing to prevent you, because I let you use idle, I believe, popping open idle, right, going into the shell, and typing in 2 plus 3 times 4, and woohoo, it's 14. There, I've answered my question. I'd rather you understand it, right? Now, yeah, you can type stuff into idle, but if you're typing a lot of stuff into idle, you're going to fall behind and you may not get to finish your exam. So don't think I'm going to enter everything on it. You're not going to have a lot of questions that rely on being able to enter it anyways. But certainly you could that. But you ought to already know. What if you had this? A is equal to parentheses 2 plus 3 in parentheses times 4 star star 2. Now, according to PEMDAS, what's the very first thing that happens? 2 plus 3, star 4, star star 2. What's the first?
2 plus 3.
Right, the 2 plus 3 happens first. So that's equal to 5 times 4 star star 2. And then what happens?
Then we do 4 star star 2.
Right, then we do exponents. Parentheses first, then exponents.
Which is 16.
So that's 16.
5 times 16 is 8.
5 times 16 is yeah. Thank you for telling me that. I would not have made it so large if I thought ahead. One more thing to make sure we remember is how to convert a math expression to a line of code. And what do I mean by that? What if we had the volume of a conical, how about just a cone? Here we go. We have an expression here, but we can't type that in. We'd have to do a couple of fixes to it. For one thing, you can't just type in pi r. What do you have to put between the pi and the r?
Like the more.
Yeah, you have to put a star there. And then between the r and the 2, you'd have to put star star. And then between the h and the 3, you'd have to put another star. And it might make you feel good to put parentheses around that. Right? So if I was going to do that, and I can't unfortunately put a screenshot of
You
that in
said
there.
a star between the H and the 3.
If I said star, then you would do a division, my mistake. So let's go ahead and convert it. I wish I could embed an image, but I can't. V is equal to pi, or 3.1419, times r star star 2 times, and I don't have to do that. I don't have to put asterisks around it, but it makes it easier to read perhaps. I'd be tempted to do this. Not necessary, but I'd be tempted. So this is the mathematical formula, but mathematical formulas, they feel free to leave off the multiplication symbols and the power of symbols, right? By the way, don't use caret as your power of. Yeah, sure, that's how we did it when we were, yeah, we can't do it in our programming language. I may as well put a comment, volume of cone, Google to see the math version, right, the textbook version. operations on strings. There's only two operators that work with strings. One is the plus sign, which adds two strings together. And then the other, weirdly enough, is the asterisk. I'm just going to go into the shell to demonstrate both of those. Like if you have A equals Joe, and you have B equals Bob, and you want to print both of those names, print, parentheses, A. Okay, technically you could do this. That would do it. But here's what I want us to be able to do. S is equal to A plus B, and then print out S. Whoa. Oh, I typed out A rather than S. My finger slipped. Okay. And so, adding A and B together, but they're strings, resulted in Joe Bob. You have to kind of be careful because if you have strings like 1, x equals 1, and you have y equals 2, and then you have z is equal to x plus y, is it going to equal 3 or is it going to equal 1, 2? These are strings. They're not numbers, so it's not going to do arithmetic. It's going to do concatenation. It's going to do appending. So, 12. I think I'm just going to copy all this. No. That'll make you feel like you have to type it all in. Why don't we put that, though, as a reminder in here? A is equal to quote 1 end quote plus quote 2 end quote. That's equal to quote 1, 2. Because they have quotes around them. They're strings. If we wanted to do math on them, you turn them into floats or ints. So the plus sign used with strings is called concatenation. Concatenation. Hope I spelled it right. Which is just a fancy word for appending. And there's asterisk as well, which means repeating. This doesn't work in any other language than Python that I've ever seen. I'm going to go close my shell and reopen it to kind of clean things up. Right, if I do this, print parentheses, Bob, end quote, times 3. Bop, bop, bop. That can be useful. Like if you want a line of asterisks, print parentheses, quote, star, end quote, times 30. Got 30 asterisks. Never seen that in another language, but kind of cool. Not going to be on any of your MindTap tests. Not going to be on my exam. Just remember it if you need a quick way of printing a lot of dashes or asterisks or something to make your output pretty. Seems like I have several copies of this open now. Input, we know how to do input. If you're doing input inside PyScripter rather than idle, it pops up this cute little dialog. We're not, so. Composition is the art of taking a formula and turning it into an expression, which is what we just did. Pi r squared is equal to, right, 3.1199, whatever, star r star star 2. And occasionally I throw this one at you, to where you do both the printing and the input and the conversion all in one line, just to save yourself some typing. And every time I do that, either I forget to close it with the second parentheses, or you do. And when I say you do, you know, some small percentage, and it's an easy mistake to make, I do it too. You require 2 closing parentheses because you had 2 opening parentheses. They have to be matched. All right. And this is say, if you want to be tricky, you can write it all in one statement. Now here is how to get input, perform a calculation, and then display the output all in one line. Now that's crazy talk. There's no reason to do that. Such compact code may not be understandable for humans. But computers work. I mean, it would do it. There's no reason to try to write your code like that unless you're just trying to deliberately, make your coworkers angry at you. The modulus operator. 7. Modulus 3 means 3 goes into 7 2 times with a remainder of 1. Glossary. Assignment operator. Composition, the ability to combine expressions and statements in the longer ones. Here they're calling it an assignment token rather than an assignment operator. The textbook, I believe, calls it an operator. Every other language does. Every other page does. I'm not going to call it an assignment token. So far, we've talked about 3, maybe 4 different data types. So data types. Float is for floating point numbers. Int is for whole numbers. Strings are for whatever you type in the keyboard. Now you can stick numbers between the quotes, but they're not really numbers, right? They're just stuff typed in a keyboard that you would later have to convert. And then one more called Boolean, which is either a true or false value. Don't think we've done much with that. I don't think I'm going to wind up asking you unless it's prominently featured in the next chapter, which I do not recall. In some languages, you have to declare the data type of the variable. I'm going to type this and then erase it. But for example, in C or Java, you have to do something like this. Int x equals 1. I hear people typing it. Maybe I could leave it. I don't know. But in Python, you don't have to give a type. Python picks it for you based on the data. So if you type x equals 1, perfect. Python decides it's an int. Makes it a little bit easier. The other languages produce executables. They are compiled. So they're more picky about data types, which is why you have to declare the variables with a data type. So in C or Java, you have to give a data type, but in Python, you don't. The reason I'm harping on this is when you're looking at code examples in the book, you're going to see a lot of this. Int x equals 1, float pi equals 3.14159, stuff like that. Or you'll just see the word num. The textbook is pretending that you can declare every variable a numeric value just by using num, which makes sense, I guess, for pseudocode, but we don't need to do that. Alrighty. See how fast we go through this? Chapter 3, Hello Little Turtles. We've played with turtles. I'm not going to play with them again today. You feel like playing with them? Cool. Check this page out. It tells you how to change the background color. It tells you how to give a title to your window. It may tell you how to change the size of the window. It gives you an example of creating more than one turtle so that you could be drawing multiple things on the screen at the same time. And then suddenly it pops into the for loop. This is the wrong time to introduce it, but I guess they're kind of like me and feel like throwing stuff at you before there's actually, mention of it in the text. A for loop that iterates through this list. Something tells me that Angelina and Brad were big in the news when this guy wrote this. Did he really have 5 kids? I don't know. We have used for loops in our turtle drawing programs, but we certainly did not do it in that syntax. Instead, we used ranges. for I in range 4 to draw a square, 4 sides for I in range 3 to draw a triangle. There's absolutely no reason you would want to do it like that, but it would draw a square because it's iterating through 4 values. However, it's not using I anywhere. So these values don't matter. They could all be 1,000, or they could be, Brad and Angelina and, whatever. I'm scrolling past this stuff because, like I said, it's about turtles, and also it's kind of the wrong time to be introducing for loops. I could be wrong about that, but I think we've done for loops a lot already with the range statement. That's really what I want you to know. Here's a cool thing that it mentions. You can lift your pen up, and then you can make the turtle go forward, and you can put your pen back down so that it's not leaving a line, right? If you remember that these were originally mechanical turtles, lift the pen, move, put the pen back down, and then keep drawing. You can also change the shape of the turtle. You don't want it to be a little triangle. You can say alex.shapeturtle, and there's quite a few different shapes you can use. And kind of childish, but whatever, entertaining. Now that's kind of neat code. That's using a function we didn't use called stamp. If you call stamp, whatever the cursor looks like, it leaves a copy of it on the page, right? Kind of neat. Maybe we'll do that. Righty. Enough about turtles. Chapter 4, functions. We have used functions, but we were calling them modules. I'm going to slow down here because this is incredibly important. If you learn the idea of modules and you learn the idea of loops, then pretty much you are a programmer at that point. Now there's a lot more to it than that, right? But those are like the fundamental things. And that's why computers were invented was to perform loops, right? Using loops to crank out, artillery tables, right? Or calculate the amount of uranium required in atomic bombs. The United States used computers to do weapons, and the British used computers in order to crack the German codes. Anyways, all repetitive things. They needed loops. But anyways, here's how you define a function. You use the def keyword. You give the function a name. If the function needs data to do its work, you list parameters inside the parentheses. Since we're tabbing the next line, you have to have a colon in the line above it. Half the errors I see when I'm wandering around are the absence of colons. No shame, because I do it even when I'm up here. Other languages don't use colons, they use curly braces around both sides. You're going to see that in the textbook a lot. That's called the loop header, the function header, the module header. The module header gives us the name, gives us a parameter list if need be, and in some languages it also tells you what it's going to return. In those languages, instead of the word def, you'd see the data type. This function is supposed to return a float. So it would say float space name, parentheses, and then some stuff. And then if there was a return statement, it would be returning a float. That's defining the data type. Python doesn't do that. Why am I mentioning that? A lot of code examples are going to show it. So just accept, when you're looking at code examples in the book, that they may be defining return data types, but that you don't have to do that until you go to another language. More turtles. Doc strings, we've been kind of skipping doc strings. We've been using them, but basically we've been using them for comments. You could put a doc string at the top of every one of your functions like that to describe the function. And then if you did help on that function, it would print out that doc string. Let's see if that's strictly true. Let's make sure I have the concept right. I don't use doc strings because they're a Python specific thing, but we're going to try it. All right, so I'm going to close this comment with my triple quotes. And I'm going to define a function called hi, def space hi, parentheses. I'm not going to even make it where it can accept a person's name. It's just going to print out hello. So parentheses, close parentheses, colon. Now I'm going to put a doc string in here. So triple quote, make turtle T. Okay, this quote's going to say, this function prints hello. And then close your triple quote. The next statement's just going to be print hello. That's all the function does. So print, parentheses, quote, hello. End quote, in parentheses. And although it's not strictly necessary in Python to put a return statement, the book's going to be showing return statements everywhere, so I'm going to put it. What do I mean by that? Why it's not strictly necessary? As soon as Python hits an unindented statement, it returns anyways. So it's kind of optional. Nothing wrong with putting it there, especially because pseudocode always puts it there. And then let's call the hi function. So hi, parentheses, in parentheses. And let's run it. All right, so it printed out hello. I'm feeling good. Now what I'm really curious about is if that docstring works. If I can come up here and type help space hello, well, what do you know? How about help space sum? Help parentheses hello? Oh, what did I call my function?
Hi.
I called it hi. So help parentheses hi in parentheses. And it says this function prints, well, okay, I made a typo. But it tells me what that function does. Just like other functions like sum, help parentheses sum in parentheses, tells me what the sum function does. Gives me a whole bunch of information about it. So the docstring that they created, doc's short for documentation. The Python programmers who wrote the sum function put a whole bunch of documentation in it. So it's not a bad idea to do this. I ought to do this in every function I write. It's more typing. We never use the help function. But it's a good programming practice. And it's always a balance between showing you good programming practices and making the class short enough that we can get done in an hour and 10 minutes. So I guess I'm going to add a comment. The quote, quote, quote defines a docstring which will be printed if we use the help function. For example, comma, help, parentheses, hi, in parentheses. So you might remember that. If you're stuck on what a function is supposed to do, go to the shell and type help with a P. I mean, you could type the other one, but it wouldn't do anything. Give you syntax error, unless you wrote a function named that. The book certainly doesn't mention docstrings. Is it going to be on my quiz or one of the book's exams? No. Is it important? Well, it's part of good professional programming if you're a professional Python programmer. Why is it a good idea to do it that way? Because quite often you will see, and really you do not have to type this, honestly. If I was going to write a function in another language like C, C++, int add, and it took two parameters, int x, int y, parentheses, this is what it would look like in that language, and then int result is equal to x plus y, and then return result, right? That's how it would look in C or Java, one of those C-based languages. And then somebody wants to describe what the function does, they start adding comments. Add function, and then they would describe it. Int x, comma, int y. They put a lot of information in it, right? And then, adds x to y and returns the result. Instead, we would put that in this language as a docstring, in our language, so that we could do help, parentheses, add, and it would kick out our comment. The docstring is better because if you're doing this in the C language, there's no way to get it to kick that help, those comments out. And you'll see me slip into that other mode to where I start adding comments above our functions, right? You've seen me do that before, or out to the side of them or something. You know, this is the whatever function and it prints hello, right? You've seen me do this. This is a better way of adding a function comment. All right, I'm going to make this go bye-bye. That's cool. That's neat how they did that. How did they make each line a different color? They defined a list of colors. And each time it drew a side of a square, it switched to the color. First red, and then purple, and then hot pink, and then blue. That's pretty nifty. Functions can call other functions. So if we do this, define A, parentheses, in parentheses, colon, and it prints A. Well, why don't we not even put this inside a comment? Print parentheses A, in parentheses, and return out of that. And then we do DEF B, parentheses, in parentheses, and it's going to print, whoopsie. We don't have a variable called A. I meant to put quotes around that. So go ahead and put quotes around the A. And B is going to look the same. It's going to just print out the letter B. Print, parentheses, quote, B. And then we're going to make and then return. The next function is going to call both of those. DEFC, parentheses, in parentheses. And what does it do? It calls the A module, A, parentheses, in parentheses, hit return. B, parentheses, in parentheses, hit return. I should say B, hit enter. And then the return keyword. Like that. And to get this to trigger, I actually have to call the module. So underneath all that, unindented, probably about time for me to wander around and make sure nobody's got syntax errors, because some people are shy about interrupting me. Please don't be shy about interrupting me. You earn brownie points in my mind if you interrupt me. All right, and so what is it going to print? What does C do? It jumps up to that module, which calls A, so it's going to print out A. Then it's going to return out of there, which brings it back to here. So it's going to print out B. Jumps up here, calls the B module, prints that out, and it returns. So it's here, then it hits that return, and so it comes back to here. Let's change the order. Let's make it print B, A, and then one more call to A parentheses, and then one more call to B. So when it runs, it's going to print out a B, followed by an A, followed by an A, followed by a B. If I don't have any syntax errors. Yep, BAAB. So functions, modules can call modules. If you want to learn an advanced programming technique called recursion, a module can call itself. Not a real good idea in this point of our education. What do I mean by that? If I do a function that calls itself like this, DEF space D parentheses in parentheses colon, and what's it going to do? It's going to print parentheses quote D in parentheses, and then it calls itself like that. And then down under here, I better unindent it so that I can call D parentheses in parentheses. Not really useful. Eventually it's going to crash, because each time a module is called, it has to store something in memory to keep track of where it is. And since it just keeps calling itself, it never gets to release that memory. Kind of like the shampoo instructions. Wash, rinse, repeat. Right? So if you repeat it, what are you supposed to do? You wash and rinse and repeat it again, over and over and over. So that's recursion. I'm going to delete that because it's a syntax error. And then I'm going to wander around and make sure that we're all doing okay. What's going on here?
I'm trying to understand.
Right. So
that
the
point.
C function, this is the function name.
Right.
The C function calls the B function, whoops, not cax, calls the B function, and then the A function, and so on, right? It does it 2 more times. It calls the A function and the B function. So when we call C, it jumps up here, and then it starts doing these things in order.
Okay. I got it.
Yeah.
All right. All that. So whatever the function name and empty parentheses together, that's just basically calling that function.
Right. And why are the parentheses empty? Because this parentheses is empty. If this had a variable in it, we'd have to pass some data into it.
Right. If you just want to call a function
Without passing any data, it's the empty parentheses. Exactly. A common mistake is to leave the parentheses off. Well, I'm going to call the A function. Don't do this, because that breaks it. Wouldn't necessarily break it, but it wouldn't do what you want to do. In other languages, it would break it. In Python, well, let's see if it'll break it or not. No, but it certainly doesn't do what we wanted it to do. It doesn't call it. So we better put that back. So the homework is an interest calculator. When I make a homework document, I'll copy and paste the interest expression, the formula for it, into a Word doc, which I can't do here. But we can Google it up. Interest formula. Here's what it looks like. In order to solve this, we're going to have to know what P is. We're going to ask the user for P, which is the starting amount, right? $1,000. We have to know R. That's the interest rate. So like 5% is 0.05. If you just typed in 5, it'd be 500% interest, which would be really cool, but your bank would not like to pay that. And then N is the number of times a year, right? You could have annual interest, 1%, or you could have, quarterly interest. You put in 4, you could have monthly interest, 12. And if you were really awesome, you could have daily interest. I don't know how you'd ever arrange that. And then you have the N, which is a number, again, that's the number of times per year. That variable is used in 2 places. And then you have the time in years. Now again, we're working on evaluating, converting expressions into code. We better put parentheses around the N and the T, right? We definitely want to make sure that those are clustered together, because exponents get done before multiplication, and if we didn't put parentheses around it to force that to happen first, it would calculate all of this, and then it would multiply your result by T, and you'd get the wrong answer. So like I said, I'll paste that into our Word doc. And then what's the assignment supposed to do? Ask the user for P, comma, I, which stands for interest rate, or was it R?
R.
R, yeah, and then N and then T. So I'm going to put some comments. Principal, R, which is rate, N equals number of times per year, and then T equals the number of years. I would convert them all to floats. Ought to work the same if they're ints, except the interest rate has to be entered as a floating point number. And then use the interest formula to calculate and display the final amount. If you get totally stuck on expressing that formula as Python, text me and I'll do it for you and I'll send you a picture back. But you ought to be able to do it. And like I said, I'll paste that formula into it. That makes sense, gang? I'm going to go ahead and make the Dropbox, so I'm going to tab away from this for a moment so that people can bail. So people have a class immediately following this. I wish Windows would let me drag it off the screen. Guess if I'm super careful it would. Alright, anyways. Any questions over that? Is that kind of making sense? If you get stuck, text me for help.